This is Algebra 2, page 1124. We're going to do page 21 and 22. I'll do quite a few of these just to make sure that we understand them, because there's a lot of factoring, the difference of two squares, multiplying the difference of two squares, so we'll make sure we understand everything, okay? So the first thing that you have on page 21 is you have the factoring the given integers and monomials by using prime factors. Okay, so when you have your variables, they're going to remain the same. So my answer is going to it's going to have that x to the third in it. But how I solve this 160. So remember, prime numbers are numbers that can only be multiplied by 1 and themselves. So prime numbers are 2, 5, 7, 11, 13, 17, 19, 23, and so on, okay? So we're going to start, whichever way you want is fine, but for 160, I'm going to start with 5. And how many times can 5 go into 160? So you can do it on the calculator. You can learn to do it by hand. You can do it in your head. Whichever way you choose, doesn't matter. But it goes into it 32 times, okay? So now what other prime number is going to go into 32? So I know that 5 is not going to go into 32. 3 is not going to go into 32, but I know 2 will. So my other prime numbers after that are 7, 11, 13. None of those will go into it, so I'm going to go with 2. So 32 goes into 2 how many times? Or 2 goes into 32 how many times? All right, 16. So I'm going to go with 2 again. 2 goes into 16 8 times. I'll go with 2 again. And you just keep doing this process until you get to a prime number at the end. Okay? So now that I've finally made it to a prime number, what I want to do is know how many 2's do I have. And I've got 1, 2, 3, 4, 5. So it's going to be 2 to the 5th power times 5 times x to the 3rd. And that is your answer, okay? So those other three that are on this page, 2, 3, and 4, you should be able to do those no problem on your own. I'm going to erase that because it was running over into my other problem. Okay. So now what you're wanting to do is factor out the greatest common factor between these, okay? So my numbers, my terms that I've got is 16, 8, and 32. So what do you recognize that between all three of those? Well, they're all even numbers, so obviously 2 goes into all of them. From there, you just want to kind of bounce around to different numbers, but you should immediately notice that 8 goes into all three of them. So the first thing that I'm going to factor out of this polynomial is an 8. Okay. Second, I'm going to look at my variables. So I have an x to the 4th in the first, and I have an x to the 3rd in the last one. I don't have an x in that middle one, so I don't want to mess with it. So with just like between 8, 16, and 32, 8 goes into all three of those. We used 8. It was the lowest number. It's the same thing with your exponents. When you're dealing with your variables, you'll factor out the lowest exponent that you have. In this case, it is 3. Okay, so then your last one is y to the 2nd, y to the 3rd, and y to the 4th. So again, all three of them have a y, so we're going to factor it out. We are going to factor out y squared because the square is the smallest. All right, so when I factored out the y, I realized that we cannot factor out this x to the third because there's not one in this middle. So, sorry about that, but just erase that. We'll fix it. Okay, so now we'll open our parentheses. And then the first, so what we're doing is 16 x to the fourth y squared divided by what we're factoring out, which is 8y squared. So 8 goes into 8 one time, 8 goes into 16 two times. The x to the fourth remains the same. And then y squared and y squared cancel. So that leaves me with 2x to the fourth. Okay, so I'm done with my first one. So now I have negative, bringing down that negative, I have 8y to the third divided by 8y squared. So that 2 is going to go away, the y is going to go away, and that 3 becomes a 1, and the 8's cancel. Leaves me with negative y. And then the last one is going to be 32 x to the third y to the fourth divided by 8y squared. So 8 goes into 8 one time, 8 goes into 32 four times, bringing down that positive sign, bringing over the x to the third, and then y to the fourth divided by y squared is y squared. All right, so that is your final answer on that one. 8y squared times 2x to the fourth minus y plus 4x to the third y squared. All right, so on this next one, what you have to do is you have to multiply the two binomials and then add your like terms. So I'm going to do the full method, first times the first, outside times the outside, inside times the inside, last times the last. So x squared plus 3x minus 4x minus 12. Okay, that's my first set. I'm going to bring down this addition sign. And I'm going to do the same thing over here with this other one. X squared times plus 3x minus 9x minus 27. And then from here, I'm going to add like terms. So I've got x squared. I got positive x squared. I've got positive 3x. Let me change the color. Got positive 3x, negative 4x, positive 3x, negative 9x, and then negative 12 and negative 27. Okay? So positive x squared plus x squared gives me 2x squared. Positive 3x minus 4 is going to give me negative x. So this is negative x. Positive 3 minus 9 is negative 6x. And then negative x minus 6x is negative 7x. So I've done that one, did these, I did these. So last is negative 12 and negative 27. And that is going to give me negative 39. So that right there is your final answer for this problem. Okay. Moving on. So these are the ones that are a little bit more complicated. So what you're going to do with this one is you're going to say since this is the cubed root, I want this to also be a cubed root. And so the cubed root of 27 is 3. How do I know that? Because 3 times 3 is 9. 9 times 3 is 27. 1, 2, 3. So what I'm going to have is x to the third plus 3 to the third, or x plus 3 times x plus 3 times x plus 3. Okay, so then I'm going to do the full method with one of these. Only one, not the other. And it's going to be your final answer, x plus 3 times x squared plus 3x plus 3x. So remember, square the first, multiply the first times the second, and then double it, so 6x. And then the last times the last is 9. So this is, oops, sorry about that. This is your final answer on this one. So again, this is all factoring. This is all review of Algebra 1. So I'm going to move quickly through these. And if you don't understand one, just pause it, rewind it, start over, see if you can't figure it out, okay? So here we're needing factors of 4 and factors of 9 when added together give us 12. Okay? So my first sign, or I'm sorry, my second sign tells me that both of my signs in my binomials are the same. The first sign tells me what those signs are. So if that last sign, if that second sign is positive, my signs are the same. If it is negative, my signs are different. The first sign tells me what those signs are, if they're supposed to be the same. Okay, so now factors of 4 are 2 and 2, 4 and 1. Factors of 9 are 3 and 3, 9 and 1. So what I need is to be able to multiply them together, multiply them, and then add together and get 12. So 2 times 3 is 6. 2 times 3 is 6. And 6 plus 6 is 12. So obviously I'm going to use those. So 2, 2, 3, and 3. So your answer here is going to be 2x plus 3 squared. Why is it squared? Because both of these are the exact same. All right. Number 15, it ends up being a difference of 2 squares. So the first thing I'm going to do is I'm going to factor out that 3. Because 3 goes into 3 one time. 3 goes into 75 25 times. So factor out the 3, and I'm going to get a squared minus 25. This is a difference of 2 squares. A difference of 2 squares means you're going to factor it out into 2 binomials. So the square root of a squared is a and a. Since this is a negative sign and it's the only sign that I have, I'm going to have a negative and a positive. And the square root of 25 is 5. So my final answer is 3 times a minus 5 times a plus 5. Okay, moving on down to number 19. I have 12x squared minus 25 plus 12. So again, that second sign is going to tell me whether my signs are the same or they're different. Since it's a positive, I know that my signs are the same. And this first sign tells me what they are. So since that sign is a negative, both of my answers are negative. The other thing is knowing that if they are the same sign, you are adding together. So factors of 12 are 4 and 3, 6 and 2, 12 and 1. Okay, so what we're going to do is we're going to work out all of these to see which ones, when added together, are going to give you 25. All right, so you can do 4 times 4 is 16, and 3 times 3 is 9. So you get 16 and 9, and when you add those together, you get 25. So sometimes you'll recognize that immediately, which ones you're going to use and which ones you're not. And sometimes you don't. Sometimes you have to think about it and you have to work them all out. But in this case, it was kind of simple to figure out. So I know that I'm going to be doing 4 times 4 and 3 times 3. Okay, so I'm going to work this one first. So 4x and 3x, because when I do my first times the first, I have to get 12x squared. Now, when I put these factors in, the 4 and the 3, I have to make sure that my 4 is multiplied by my 4. So outside times the outside, and inside times the inside. Okay? So I'm going to clear that off so that I can get that line out of my other. All right? So now we're going to move on down to number 21. We'll work this one out. So again, this is a difference of 2 squares. What is the square root of 64? Remember, a difference of 2 squares is you have 2 sets of binomials and you have 2 different signs, but everything else is the same. So the square root of 64 is 8. The square root of x squared is x. The square root of 49 is 7. The square root of a squared is a. All right, so 26, you're going to factor out that 2. 50 divided by 2 is 25 minus a squared. And this is a difference of 2 squares, so you'll end up with 2 times, and then you'll have 2 binomials. Remember, you have a positive and a negative sign, and then you just take the square root of 25, the square root of a, and you'll get your answer. Okay, so we're going to do 28 and 29. I'm at 28 and 33 real quick. So factors of 6, 3 and 2. 1 and 6. Factors of 2 are 2 and 1. So I have 2 sets of binomials. I have this second sign that tells me whether my signs are the same or they're different. So since this is a negative, they are different. So negative is difference. So my signs are different. Okay. And then when I subtract, my middle number needs to be a negative. So how do I decide which ones to use? So obviously I'm going to use 2 and 1, but I can't plug them in here yet because I need to know which one needs to be the negative and which one needs to be the positive. So I look at my other factors. I have a 3 and a 2 and a 1 and a 6. Well, if I were to use the 1 and the 6, 1, 6, 2, and 1, 1 times 2 is 2, and 6 times 1 is 6. And when I subtract those, I do not get 1. And if I were to do it the other way, 6 times 2 is 12, 1 times 1 is 1, still does not give me 1. But if I do 3 and 2 and 2 and 1, so 3 times 2 is 6, 2 times 1 is 2, so that's not going to work. We already established 6 minus 2 is not 1. But 2 times 2 is 4, and 3 times 1 is 3. And when we subtract those, it does give me 1. So now what I have to do is I have to make sure that my bigger number, the number that's going to be 4, is my negative, which means my 2's, one of them has to be negative. All right, so I'm going to factor this one first. And I'm going to put my 3x here and my 2x here. And then I'm going to factor this one, the negative 2. And it's 2 and 1. And I want my 2 to multiply by my 2. So outside times the outside, inside times the inside. My 2 goes there, my 1 goes there. And that is the answer. Okay. So number 33. And then I will start 40, but I will not finish it. Okay, so I'm doing number 33 only because it's big numbers. But it is very, very simple. So my factors of 81 are several. But I do know that 9 and 9, so 9 times 9 is 81, and 11 times 11 is 121. Well, 9 times 11 is 99, and I would do that twice. And 99 plus 99 is 198, which is my middle number. So this one just turns into a perfect square. So I've got a negative and a positive. My second one is positive, so I know my signs are the same. My first one is negative, so I know my signs are negative. I'm going to use only one, and I'm going to square it because that would mean the same thing. And I got 9a, 11b. And that is it. All right. So the last thing is number 40. I'm not going to finish this one. I'm just going to let you see that this right here is a difference of 2 squares. And a difference of 2 squares factors out to be those letters or numbers or whatever. The only thing that's different between your binomials is the sign. So from here, you're able to cancel. And your final answer is, and I'll stop the video there. This should help you get through this section of the book. I know it's a lot of problems, but if you'll do them and you'll repetitively do them, then you'll end up being able to do them without even thinking. And it will just be second nature for you to factor out these binomials and notice these things. It's very important for you to notice them. It will help you when you get into college and get into more advanced algebra problems.